Hello, and welcome to 5-Minute Math. Today we are looking at the 8th grade concept of similar proportionality. This is standard 8.3a in the great state of Texas, and we are using item number 6 off the 2024 released STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. All right, so we have two quadrilaterals here that are similar, which means that their sides and their angles, well, their sides are going to be proportional, their angles are going to be congruent, but we're just looking for proportionality of their side lengths here. So one thing we need to see is that M lines up with R, but they are not in the same orientation, and that is going to make it very difficult. So my suggestion here is let's recreate this and let's just bring it over. I'm just going to kind of mimic what I see here. I'm just going to make it a little bit smaller. All right, it's not going to be perfect, but let's just make this, because if those orientations, if I'm continually having to kind of figure out the orientations, that's not really going to work. So let's see, that's going to be R, and then moving counterclockwise, right, that's going to be Q, that's going to be P, and then that's going to be T. All right, so RQ is 4.28. QP is X. They're all in feet. PT is going to be 3. And then TR is 4.12. All right, well, I didn't make a perfect recreation, but at least it's oriented in the same direction. So now we can start looking at some proportions here. And we need to see which ones are going to be true. So I'm trying to match the sides that are in the same relative position. So x over 9. All right, so x over 9. So I've got this top one over, yeah, I can already tell you that's not going to work, because those two sides, they're on two separate quadrilaterals, which is fine, but they need to be the same ones. What it needs to be is it needs to be x over 8.91. Right? Or it needs to be 3 over 9, because this x goes to that one, and the 3 goes to that one. But x and 8.91, if they're in different quadrilaterals, you cannot have them together. If they were within the same quadrilateral, you could, as long as the other proportion matched. So that's not going to work. Let's change to green. Let's say x over, there we go, 8.91. All right, so we were just talking about that. So x over 8.91, that's good. So I just need another pair that's going to work. The first one needs to be from the smaller quadrilateral. So 4.12, okay, that works. 4.12 goes with y, and you see it's 9. Wrong one. If that were going to be y, that was going to work. So that is going to be incorrect. Let's check C. Y, that's the large one now, over 4.28, and take a look what we've got. Those two do not line up. And it's obvious now. That's why I always suggest rotating it, because it might be hard to tell if they're not in the same orientation. Y would go with the 4.12, right? Or this 4.28, if we wanted to, could go with the 12.84, right? Because these two go together. But the Y and the 4.28, not going to work. All right, so it should be this last one. Let's check. Y over, and I'm going to write it over here, 4.12, right? So I've got two bottoms. That works. Y over 4.12. That's good. So then I need left side over left side, and that is going to work. And we notice that we've got this Y is going to be big. The 4.12 is the small one. And then we notice the 9 is also the big, right? So the bigs are my numerators. The small one is in my denominator. The 3 is in the denominator. So that works. My answer is D.